Hi everyone, my name is Daniel, and I'll be presenting a literature review from California on the role of sleep dysfunction in the glymphatic system and the progression of alpha-synucleinopathies. In this presentation, we will be going over the characteristics of alpha-synucleinopathies and then discuss the relationship between sleep and this group of diseases. Then we will go over how the glymphatic system is related to sleep and alpha-synuclein clearance. First, here are some important definitions. The glymphatic system is a complex network of perivascular channels that delivers nutrients and clears cellular waste products through the circulation of cerebrospinal fluid, abbreviated CSF, and interstitial fluid, abbreviated ISF, in the cortex. Some cellular waste products include proteins that may contribute to neurodegenerative diseases when they aggregate abnormally. Muscle atonia is a loss of muscle tone as well as inhibition of spinal motor neurons to prevent movement, which occurs during REM sleep. REM sleep is the deepest stage in the sleep cycle where most dreams occur. Alpha-synucleinopathies are a group of neurodegenerative diseases characterized by the abnormal aggregation of proteins called alpha-synuclein. There are three main types of alpha-synucleinopathies. Multiple system atrophy, Parkinson's disease, and dementia with Lewy bodies are the three main neurodegenerative diseases. Here is a table with the brain regions and symptoms involved in each of these diseases. Multiple studies have shown that sleep dysfunction is a hallmark symptom of alpha-synucleinopathies. Issues most commonly present themselves in the REM phase of the sleep cycle. In alpha-synucleinopathies, muscle atonia, a normal function of REM sleep, is inhibited due to neurodegeneration and disinhibition of certain brain structures. Furthermore, studies have shown that patients with idiopathic REM sleep behavior disorder are at a significantly increased risk of developing Parkinson's disease, dementia with Lewy bodies, or multiple system atrophy. The association between alpha-synucleinopathies and sleep dysfunction suggests that brain structures involved in sleep are susceptible to alpha-synuclein pathology. The glymphatic system is one potential culprit for the link between sleep and alpha-synucleinopathies. In various animal studies, CSF influx was found to be greater in sleeping animals than those that were awake. Other animals have shown that sleep deprivation is often accompanied with higher concentrations of pathological proteins such as tau and alpha-synuclein. In addition to the relationship between the glymphatic system and alpha-synuclein levels, the glymphatic system has been shown to play a role in clearing alpha-synuclein. In a study with mice, a decrease in glymphatic influx caused alpha-synuclein aggregation. Therefore, sleep dysfunction may impair glymphatic clearance of cellular waste products, including toxic proteins such as alpha-synuclein oligomers. Conclusions. We found that sleep promotes glymphatic system clearance of waste products from the brain, including pathological proteins that cause neurodegenerative diseases. Whether the system plays a role in Lewy body formation and alpha-synuclein aggregation is still unknown, however, and requires further study. So what does this all mean? We know that sleep is a symptom and factor for alpha-synucleinopathy progression, so it makes sense that medications to address sleep disorders and neurodegenerative diseases typically have sedating effects that promote sleep or help to regulate patients' sleep cycles or circadian rhythms. One common treatment is melatonin. As seen in the diagram, patients with alpha-synucleinopathies commonly show reduced brain levels of melatonin, a hormone that regulates circadian rhythms. However, once melatonin is administered, brain levels of this hormone go back to normal. Thank you for watching my presentation on how the glymphatic system and sleep plays a role in alpha-synucleinopathies and their progression.